Thank you to our sponsor HP. We'll actually be running on the Z800 workstation during this presentation. Hi, I'm Will Harris from the Venice, California Autodesk office, and I'm excited to take you through our presentation of 2D to 3D conversion or redimensionalization. We'll be looking at various techniques in the challenge of taking a monoscopic job, something that was shot mono, and turning it into a stereoscopic 3D result. We'll use camera displacement, placement of cards, as well as some advanced techniques of projection on top of geometry and viewing from a stereo camera rig. Right, so here we are in the Flame Premium timeline, and I'll just start by playing you back the monoscopic master for this really cool piece.
What's going on here? Come on, fella.
I'm sitting in a railway station, got a ticket for my destination.
Mr. Dove.
Hi, Mr. Dove.
On a tour of one-night stands, my suitcase and guitar in hand. Every stop is neatly planned for a poet and a one-man band. Homeward bound, I wish I was homeward bound.
The first step in taking an existing mono timeline and turning it into stereo, the way is really just to duplicate your layers here. So if I just take a copy of this guy here, and I'm going to take these two layers and do what we call a stereo merge. That produces two mono layers here. That you can see I've got a stereo track now. If I add a layer to this, what I actually get here is a double layer 2, if you like, with left and right. So if I just take like a mono graphic here and drop it into place, you'll notice that this gives me this graphic here. Of course, there is no offsets yet. If I look at the anaglyph view here, you can see that it's just sitting there. But if we then just work on our actual stereo axis here, we can do things like adjust the convergence. And if I show you full screen here, what I mean is that I can take a mono element and do simple convergence right on the timeline. That's the building process, and by starting with two monos, my timeline is set up to receive whatever effects I build in batch effects to create stereo. So as I look through the content here, there are certain shots that are going to lend themselves well to being converted 2D to 3D. Some of them because I already have compositing elements. Others are simpler shots that we're going to look at, kind of a variation along the way here. Some are going to be more complex. Certainly the shots that may be the first ones you take a shot at would be comps that you've produced yourself, because the nature of doing your visual effects work will include building things such as mats, building depth, building camera adjustments as part of your compositing. If we jump right into this shot here, I'm using the action environment here, and the shot is essentially a fly through this environment here. If I take a look at my working view here, what you'll notice is that the very nature of the action environment is that it is a camera scene environment. It's a 3D environment with these still cards laid out in space. So it's pretty straightforward then to just come right down here, and if I show you the camera up close here, you'll see when I throw the switch between mono and stereo, what I actually end up with is a standard FBX camera, common to other software in the Autodesk family, that I can then adjust, change the interaxial distance if I want, change the type of camera, but without really any adjustment. I can just take a look at my result view here, and just as is, you can see that I have a stereo result right off the bat. If I change interaxial settings here, they're going to start to change. If I move the position of the zero parallax, you'll also see a change. So if we go back to our sort of perspective view here, what you'll be able to see here is as I move around my environment, this red card here is this zero parallax plane where I can define what I want to call the screen depth. So say I put it between those two ranges of mountains here. That's defined that as the screen depth. And if we come back to look at our result real quick, you can see that I've now built essentially a different kind of feel to this. I could manicure this as I like, set the depth, the amplification of the stereo to suit myself. So let's look along to another example here where what we have is a kind of a work in progress shot here using a green screen element. This is a bird flying towards a wall is what it's going to be. And we've got a logo here. We're also looking at building out essentially a curved wall in this place. It's one of the ideas for this shot was to build something that looks kind of like this, where the bird's flying. As we scrub forward here, you can see the bird is going to land right on the wall. So this is another shot that lends itself really well to 2D to 3D conversion. What's going on here, if we just take a slightly closer look, you can see we have our substance generator. This is actually the how we generate the bricks here. You can see the number of bricks, the size of the bricks, the age of the bricks are all adjustable here via the substance generator. That's a procedurally generated shader. We also have essentially a logo here, or this beer bottle logo dropped onto the scene as what we call a diffuse map. So it's just being projected on like a projector. And then the bird here is laid out and set out in space to really land on the wall. So if you just take a look from this point of view here, you can see how it works as as the bird flies in. If we go backwards in the shot, you can see it comes out. The shadow is reacting. Things are reacting in 3D as you'd expect. But the reason I came in here, I wanted to show you how specifically when I do that same technique of switching to stereo, I'll of course get a stereo result over here. And this is very clear, I think, how easy it is to work when things are physically laid out in space. So as I bring the bird in close to the wall, you can see how it really does appear to sit near the wall, and that's because it is. It's really quite close there, and you can get the idea that if I move it back and forth, it's going to behave in a way, even if I go through the wall, you can get an idea that all of these problems of alignment are solved for you by this sort of physical layout of this action environment. So what about shots that are not visual effects shots? If you just take a look at some of these raw shots here, we can actually use our batch effects environment. That's the full batch environment of Flame, even though we're working in Flame Premium timeline here, to actually pull out individual procedural nodes here and actually do any of these functions in stereo. So we can actually work procedurally in stereo here, but specifically we want to pull out our action environment, which has a special stereo function where it can take a mono source and produce via that stereo camera that we just saw a stereo result. So if I plug it in here, this feeds back into the timeline for this particular shot. But what we'll do is we'll just take the mono source and do a displacement technique on this shot. You can see right off the bat the issue that we have when we just put a flat card in front of a set of cameras. We have a stereo environment with a flat card in it, so that's not going to quite produce the result we're looking for right away. But we'll use some techniques here that are quite useful. So we'll take a displacement map, we'll use the image itself to displace its pixels. It looks like this in the schematic. And the idea here is to actually do an adjustment of those pixels back and forward, and you'll notice that you do actually get stereo adjustment or stereo offset. Looking here at the anaglyph view, which is an easy way to view here on the web, we have that effect working right off the bat. Let's go ahead and soften it out. But you can see part of the problem here is that we're using flat displacement at this point, or we're just using we're not observing the camera frustum. So let's switch to camera-based displacement. That keeps the pixels in exactly the right position from the point of view of the camera. So this is just a neat technique where you can now see we do have a proper stereo view over here, which is making a bit more sense. I'm using the luminance as Z depth, or displacement as we call it here. And this can get you very quickly a proper laid out stereo effect. If we take a little bit more time on this one, you could imagine how you might use something like a histogram node here to further refine what really is the luminance data that we're using here to say, okay, we want to neutralize the clouds from the sky and call those guys kind of the infinity. Let's then add on a gradient, which we're going to just sort of multiply in with this. So we'll do actually a screen blend of this. Decide just how we want to sort of nuance that distant area, the light as where we're working at, so a white is far technique here, and the darker area is closer to us. That fed into the same action environment here gives us a slightly smoother way of looking at things. And if I just show you around the cone here, you can see how we can even come and take a look around inside to feel out our displacement as an effect here. And in just a couple of minutes, you can produce yourself a pretty good looking stereo effect. Alright, so we'll plug this in and get back onto the timeline to look at some more shots in our timeline here. Lighting is another technique that could allow you to get a quick 2D to 3D effect. We have a volumetric lighting system here in the Flame Premium, which is a really cool tool for this kind of stuff. If I wanted to, I would just start using that same action environment here, and we'll take this guy in as a layer. We'll just connect him into our scene and also pull in a background there, because what I want to do is I want to key the sky part away from the rest. So in order to generate some light coming into this scene, a little more dramatic effect, we could use one of our many keyers. We'll actually just use the Luma keyer here to pull out essentially the sky, the highlight area here, and define it. We want actually the inverse of that. We want to cut a hole in our plate that then produces this kind of an effect. And then we'll add some lights into our scene here to generate a lighting effect. So let's start with just a light in the foreground, which we'll just pull all the way back to normal, and then a creative light. So a way of we'll put our light into our scene here, send it backwards in space, and see if we can't drive not just the light, but add some real visible light or volumetric light, such as light rays here. So this is a good technique for getting a real volumetric light. And the thing I wanted for you to notice was the way that the light rays themselves here in the anaglyph view are getting a stereo effect. And if you do put your glasses on, you'll be able to see, with and without your glasses, the effect of the stereo, if you like, applying itself to these rays. And certainly if we just set our light here for a slightly more subtle effect, you can get the idea that this is something that's reacting properly in 3D space. Even though it's just working with a flat plate right now, you can see how it reacts itself as a 3D element in space. So this is just a neat starting point for a shot like this to get something going. Let's look at how we could migrate this across to multiple shots in the scene. So if we come to this shot, and then over here we'll take a look. There's another shot a little further down here of similar content. And it's really just a matter of selecting those and then dropping in our guy here. So if we come back to this guy and drag and drop our effect onto the other two, you'll be able to see the instantaneous kind of reapplying of that procedural composite on the different shots. So this might be a template that we go ahead and customize on the different shots, but certainly gives you a good idea how you can get that that stereo lighting available right away. So that's a cool effect, and certainly quick and easy to do. But what about getting down to the nitty-gritty of shots which are much more intimate, that really need multiple layers of depth, or where we might have to take what we call cards, separate layers, cut out layers, and add rotoscoping to really define different layers in the scene as we choose. So that's what we want to look at next. What I'll do is I'll just give you an example with this shot, where what we have is a scene that has got some certain definite layers of depth within it. From the box in the foreground here, the hand, the bird, this hand, the head, and so on. So you could choose really just how complex you want to make this, but you're certainly going to need 3 or 4, maybe 6 layers of depth. And the face here may even need to use that displacement technique within a set of cards to get a difference between the nose, the mouth, the chin, the eye sockets, and so on. So let's just sort of tackle this one in a couple of steps. The hand here is really the sort of the most organic movement that we see in our scene, so that's certainly going to be an interesting challenge for tracking. What we'll do is we'll drop in a cool mask here, our G mask, right inside of action, and draw around this hand. And we have a bunch of different trackers in the system here available to us. We have point trackers, we have bilinear trackers for corner pinning. We also have a new tracker here that I wanted to show you called a shape tracker, which actually does a planar analysis and essentially picks hundreds of points within a scene like this to generate a result to follow this movement. So if I just take my mask here, go down to the tracking tab and hit shape track, what you'll see is it's going to do an analysis picking essentially the content that's good about this, which is really in the middle, not around the edges, but the middle and essentially that movement that is inherent in this shape. And of course I can further refine this if I'd like. I can take a shape like this, I can pick the edge, I can go ahead and decide that I want to scale up a certain section of my mat. Here you can see I can grow it, adjust it. I'm going to tweak a little bit more here so you can see how I can even out the edges and tweak in different pieces based on a centroid point, which is really neat. I can also add a nice softness edge here with just the amount of vertices that I think I need here, and you can get the idea how we can blend the edges quite nicely here. So now I want to take this card and take it and move it back and forth in front of the camera. But what I don't want to do, of course, is to make it change size. You can see the stereo effect happening as it comes towards me and goes back. But what I want to achieve here is actually what we call an auto scale that brings the element back and forth in space, but at exactly the right size in front of my camera scene here. So it's just a great way. It's holding its perspective perfectly and gives us a way of placing things directly in space at the depth that we want them in that sort of physical layout that we mentioned earlier. So a shot like this would really need to be broken into 5 or 6 layers of depth with these cards, but specifically the face may need to be further refined, perhaps using that displacement technique that we used earlier, where we actually get different levels or different grades within a mat, if you like, to actually build up the detail for a face. This might be the moment where you start to realize that this process could be quite a collaborative one. It may not be that one artist can handle all these things. It may not be that you want to tie up your Flame Premium workstation to do this kind of work. So this is a great fit for a product that we make called Autodesk Flare that allows you to perhaps convey intent to another artist and then adjust further from there. So for example, if what you were looking to do here was to make a starting point that you wanted another artist to pick up on and actually go ahead and draw this a depth map for the face and perhaps even go as far as a much more detailed idea and track it in and so on. What you might do is just get the basic idea going here that what you're trying to do is build some depth, build out the eyebrows in a different color and so on, and the mouth here as different levels in depth, and then have another artist take it further and perhaps produce multiple versions of this shot for your review. So that's exactly what I wanted to show you here. Without any further ado, I'll just take this timeline, step back here, and show you how I could just save my timeline back into a library, like for example here. So by doing nothing other than saving my timeline, I'm then in a place where that job could be picked up and further worked on another workstation. So now I'm working on a Flare workstation. This is actually a HP 9400, probably kind of an older workstation that you might repurpose to use as a Flare. There's a whole bunch of different hardware platforms you can use with Flare. But here's a great technique where we actually do what we call remote frame store access. So I'm accessing the machine, that Flame Premium machine that we've been working on, directly. I'm actually going to enter the same project that is active there in the Flame Premium and pick up the work right from the library. So if we just take a look here, you might remember I made a 4 flares Dropbox, and then this is the timeline that I can pick up and work with and manipulate directly. So if we come in here, you can see here's the timeline, same thing that we've been working on, and then this here was the shot that we were working on. So if I just step into that, you'll be able to see how this is exactly as it was left, with the little paint stroke as an instruction to me to start work, and then indeed the sort of master comp, the action environment here ready for me to continue work on. So the paint stroke is something that I build up in a number of steps here, but just so that you can see how we'd work, we probably would go a little further, get something looking a little bit more like this. Just a still at this point that will allow us to track in this information for the face and really get realistic displacement, difference between the nose, the cheeks, the head, and so on. And the way I work here, I'll just add in an extra input. This could be something that a different artist is working on, building out this comp in a bit more detail. So let's just take a look at one of the interesting parts of this shot. I have my still here, and what I'll do is I'm just going to drop it in as a screened element. I'll just keep my hand mask isolated to just the hand layer at this point. But what we're interested in is taking this guy right here and putting him so as that he'll really work for the entire shot. He's just sitting in place there, but we'll use our tracker, this time a 2-point track, to actually dial in the way this works. So if we come up here, just grab, for example, the edges of the nose here and do an analysis of both trackers. What you'll be able to see here is we can get that movement locked in and be able to actually get the move of the nose. And I think actually if I complete that backwards to the beginning of the shot, we'll have a good set of track data which I can then work with. So far here on this workstation I've got this move right here. So what I'll do is I'll attach this below the layer here and refine it a little bit further by taking another axis node. Let's just grab this one right here, put him in there, and what I'll do is I'll just sit him in place and just dial in an offset here that will actually work for us. So what's important now is that we get a lineup that really works. We can take a look at that here by just checking the alignment of the eyes, maybe tweak it a little further. In this case, this should work pretty well to hold the basic movement and get the profile of this face. So the next step would be to, rather than use this as an image, we'll bring it in as a displacement map. So one of those tools that we used earlier. We'll just connect that directly into the track data that we just created. And now you'll start to see the effect when I move this back and forth in depth. So if I just emphasize that a little bit, you'll be able to see how we can get movement to actually dial that out. If we actually look at this in perhaps a sort of a wireframe view here, you can really come to understand that this is just a great way to get real movement data dialed in. If I just look specifically at this, you can get an idea that what I've done is I've actually dialed out the face, and we can check the accuracy of it as it moves. Look at it a little bit bigger here. You can really see how in the different directions I can then judge exactly how I want this to look, choose how much softness I want to apply to this displacement perhaps to get the overall feel that I want, change the depth to suit so it really does look like a face. And just coming back to the image view here, you can see how we've got some depth that's sort of meaningful here for a sort of a human face. So that's the level of detail that you can get into if you'd like to really break out this stuff. Of course, we'd want to use our camera-based displacement instead of flat displacement, but you can still see that this is working correctly, but just maintaining the position of the pixels from the point of view of the result camera. And certainly in the stereo point of view, you're going to start to get a slightly different perspective on the scene based on the different perspective of the two cameras. So this could constitute the first version of a 2D to 3D conversion comp for this shot. It's great to just be able to connect it right back into the timeline, keep this comp in the context of a timeline via our VFX node here. But what if you have multiple artists working on multiple shots? It's not going to be easy to have the timeline open in the right place at the right time. So to handle this kind of check-in, check-out process, we created a system called artist-driven versioning.
Every media asset that goes through your facility could potentially have versions. Our artist-driven versioning system handles this via a check-in, check-out procedure. As subcomps are created and iterated, they feed into finer comps and eventually perhaps into a master comp, which in itself could be within a timeline. Artist-driven versioning handles this versioning process.
The way this works is that you pull out an export node here. It's really a smart node that's able to include setup and version information, as well as stereo outputs here, and start, if you like, the paper trail of versioning, starting here at version 1. I'll simply take the metadata from the clip here, choose a server location where I want to put this shot, and actually start a standardized naming structure. Perhaps we already have one saved that utilizes name and version and left-right polarity tags in this case to be able to check in the first version of this comp. So if I just hit the button there, you can see that this is outputting to my server the first version of the shot. With a little more time, you perhaps would build up something a bit more like this, where you actually have a little more work going into building out the layers of a comp like this, separating out each individual piece, building the cards, if you like, in space, which look like this. And I'm about ready now to put in a version 2 of this comp, so I'll do that now. By just using that same export node and connecting it in here, what you'll notice is that I'm automatically bumped to version 2, all of the metadata is set, and I just go ahead and hit process again. And this is now going to output the second version of this comp. By the way, while I'm working here on a Flare workstation, I also have the ability to use second monitor preview for full screen preview. I'm just using an LCD monitor here, but instead of just viewing anaglyph there, which may be useful on your UI, you can also support the different monitoring formats of your stereo monitor. So you can do left, right, top, bottom, or even a grid view to support the specific input that your monitor would like to work with. So at any time I can just come back here, open up the master timeline, and just drop in my work. This could be done by one artist or a sort of a master compositor that's just dropping in comps. Let's just take this 2 version comp here, connect it in, and what you'll see is that I have the versions that I made available to me here. Here's the version 2, that's there, and I could roll back if I want to the version 1. I'm also able to add the setup directly into the comp if I want, but at this point I'm just going to work with my 2 versions there available in the master timeline. So this is just a neat way to manage easily a complex timeline. Let's plug in one more shot. So I'll just come in here and drop a batch effect on there. This is just a raw backplate, but we'll pull out a different shot done by a different artist here and drop that in. Notice that this is the smart information with the versions that I can then load right in and just connect up to my sequence here. All about this is that if I'm not happy about the way things work on either of the versions, I could roll back, or I could decide that I want to actually see the the work expanded into my batch here so that I could further refine it myself. If I was a kind of a senior compositor working on a folks' work here, what I might do is pull this out, and you can see the work that created this here. And there's a link, if you like, based on the file system between these two nodes. But I'm now able to come in, make my tweak if I'd like, whether it's refining the edges of a mat or fixing something in the way this stuff works, and then make an adjustment, decide that I want it the way I want it, and then export a version 3 here that would then tie into the next step here. So without changing any settings, I'm just able to make a new version that will then plug right into the gateway clip that's been brought in. So my timeline's now ready to be sent back to the Flame Premium. So I'll just come in here and update the name and save this directly into a new library called From Flare. So the timeline really is the container for all of these shots and all of the versions of all these shots as one master asset. So I'm back here on the Flame Premium, booting into the Flame desktop interface now. And we'll jump right into the library where we left our timeline from the Flare and use it in the batch environment. So what we'll do, we'll just take a look real quick at the shots we were working on. This one here was the one you might remember that had a couple of versions. Makes for a very light composite where we just have this guy right here. We can take a look at version 1 or version 2 and review and adjust as needed. But I wanted to take a look into a bunch more shots that we have in our sequence here. First of all, I have a helicopter shot that definitely is an interesting one when doing a 2D to 3D conversion. And then also we'll take a look at this shot here, one of the more complex shots in the interior, where we have diagonal movement, we have human bodies and detailed pieces of furniture. So first of all, let's take a look at our helicopter shot here that's flying through the valley, and we'll take a look at techniques that we would use with a shot like this. So a different set of issues. Instead of dealing with a sort of an intimate scene as we were just now what we're dealing with is a sweeping camera move with lots of depth, lots of parallax movement that really is kind of crying out for a good interpretation as a stereo result. And we're going to work collaboratively with a 3D artist here to build some geometry, but in order to build a foundation for the shot, we need to have ourselves a moving camera and point cloud or a match moved camera. To do this, we use our analyzer tool. It's really a match move tracker, a tool that's able to solve the position of the camera via figuring out hundreds of points in the image, their parallax, to generate the only possible camera solve for this move. So if I just come through the scene here, you can see how the points sit in space. If I actually take a look at a perspective view here, you'll be able to see how things look from here. If I just zoom around here, you can see how there's a natural ground as well as the rock face in the background. And this is really the foundation technology that allows us to lay out the scene and get a picture of the camera in that environment flying through. So it's just a really great technique to be able to get this working. What we'll do with this data is we'll refine it a little bit more via defining a ground plane, as we call it. So if I turn on my plane here, you'll notice that by default over here the camera is sitting on the ground because it doesn't know whether it's up or down, or essentially that it's in a helicopter. So we can further define our scene in these terms, which is very useful when working with a CG artist to lay down geometry. So we'll start here, we'll pick 3 points or more to define a ground plane, and that really locks down the grid. So you can see over here that this is just a neat way of defining how things are going to look. So now you can see that we are now in the air and the ground is really the ground. We'll rotate our plane a little bit, which is just going to turn our world around. we could then go and pick a point and add a particular locator that would be oriented based on the ground. You can attach objects to these things as well, of course. But in our case, we just wanted to define a couple of points on the ground that will allow us to set the scale of our scene. So we could decide that we think this is approximately 5 meters in size. So we'll set an overall scale here, and then when we go to output our camera, we're going to export this camera with the point cloud and set our scale in meters with a scene value of 1. So this is now ready to be exported and used in a CG application like Maya to build geometry to send back to us. So with Maya, we'd import the point cloud and camera and actually add a single sphere to the scene and replace all the points, in this example in the cliffs and the trees, with spheres. And that gives us something for a cloth type material to drop onto. We're going to use the N-cloth simulation and actually just freeze a simulation with a cloth dropped over these spheres to really give the impression of a kind of a mountain range and ground plane. So a little further along you can see the different cloths draped over the mountains and then a few spheres left in place for these trees. Rather than trying to get the individual leaves and branches of a tree here, what we're doing is roughing out the geometry, getting the correct depth, but leaving the job of fine roto and tracing the edges to the compositing tool. We're able to do anaglyph stereo viewing or other active stereo modes while we work. So this entire scene is exported back as an FBX. It's just static geometry at this point with the original camera in place. So we bring this geometry, the dropped N-cloth geometries, back here into our compositing environment, and you see how things look here. It makes sense that you're able to see it overlay with the background. To see the lineup is working out great because essentially the camera came right from here. So this is the right pieces of geometry that we want to be able to project onto, and indeed. Whilst we need to deal with a little bit of cleanup around edges like on the tree here, and up here there's actually a piece of geometry that's punching through, so maybe we could fix that up real quick. I'm just going to use my deform mesh to just pull that down out of the way, and as that was obviously just one little thing that got missed. We can make those kind of fixes here. What we'll do is we'll project our material on now. And that's done by using a diffuse map here, which is rather like a projector, where we can wrap the footage on. And then, of course, a default UV wrap is not quite what we want. We don't want each individual sphere wrapped with the image. We want a camera-based projection. And, of course, we'll turn off our shading or lighting in this situation so that we can get a result that looks like this. And if you look with your glasses on, you'll be able to see the depth in the scene. Also, I can look from a perspective view here, and if I just look at this camera projection as it sits, you'll be able to see the individual trees and really get an idea that the way we approach this 2D to 3D conversion process is really from a 3D perspective. So everything can be broken out for this very high quality projection method on geometry if you choose. So we've got a bit more refinement to do here. We talked about the trees earlier as being rough geometry, and I want to show you the issues that arise here when relating to edges. So if we look a little more carefully, you can start to see where the rough edges of the geometry start to cause problems. Like, for example, we have an artifact here over the edge of the horse, where it's being pushed forward to the depth of the tree rather than the relative depth of the ground there. So to deal with this kind of artifacting, the way we'd approach it here would be to go back to our analyzer. So you might remember this, where we had all our points that are accurate in space. And what we're able to do is to pick a bunch of points here. So let's just pick the tree. What we'll do is we'll just grab these guys. and create ourselves a point cloud. And now the point cloud is really a subset of points that can then be used for special kinds of alignment of objects. So we need to refine this point cloud a little bit. You can see that some of the points are in the back here. So if we look from our perspective view here, once again, we can use this as a great way of saying, well, you know what, these are a couple of rogue spheres there, and then these guys are really not useful for me. So I'm going to remove those. Make sure I've got just the section that I want here. I'm going to use this data here as a way to attach my mask, and what I mean by that is I'll take the point cloud over here and start the process of building myself a G-mask, which as I drag into the scene here, I'm just going to connect it right there, and then we'll start the process of drawing this mask accurate to the tree. So we'll just rough it out. And this is a really neat technique simply because it puts itself in place, and then because of the camera move, you can see that it holds position based on the camera is the moving thing, and the mask is just sitting static in the scene at just the right place. So we'll take our mask here and of course invert it and do a little bit more work on the edges. So maybe we'll just have some softness on our edges here to just blend in how things should look and get things to a point that makes a bit more sense. The next thing to do, of course, is to make our mask, instead of cut the entire environment here, we want our mask to cut just the geometry that we care about. So it's a selective mask at this point. When I go like this and have it cut just that tree, leaving the rest of the objects uncut. So it looks a little like this from a perspective view. What's happening is the mask is refining the edges of my geometry. So if we look in here, what you'll start to see is if I pull the edges out, you'll be able to see the bad edges of the geometry, and if I put them back, we can get that softer edge. Of course, the perspective that really matters is that of the camera. So we'll come in here and do a little bit more refinement so you can really see. If I get to a frame here where we were previously having trouble, now you can start to see how this solves our problem, where you have artifacts over the background that blend in. We can adjust, the soft blend here if we'd like. We'll actually just buffer this down a little bit also to get ourselves a nice smooth blend, so that now what's happening is I'm specifically deciding what I want, how I want to blend this back into the environment here. So you can really see that this is a great way of getting a much more refined edge on your geometries here. And if I just show you a little further along where I built a few more of these, you can see how you can really get to quite a smooth refined edge, picking the things that you feel need to be isolated. And then if I just show you here the kind of good looking result here, you can still get an idea of how quickly we can move through this, even though we do have the geometry being projected at this point, and we're still able to see good performance and a refined result. So if you have some experience of 2D to 3D conversion, you're probably wondering when I'm going to get to the subject of parallax effects or parallax artifacts when dealing with this kind of 2D to 3D conversion. And that's exactly what I thought I'd come to next. In an example a little further down my timeline with some more exaggerated issues. By the way, you can see that the timeline is still intact. I've been working on a shot that's a stereo output shot here in this first layer of the timeline, which has a left-right component to it. But as I spin down here, we'll move to the next example that, like I said, has a kind of extreme situation of separation of layers in foreground and back, so that you really do have this issue of parallax effect sort of thrown in your face. So let's take a look at how we solved that here. I just jumped into this comp here, and what you'll be able to see is that the foundation here is the is the analysis of the camera, just like we had on the helicopter shot. But of course here I need to do an analysis disregarding the guy at this point in time. So I'm just getting the scene here, and then we're going to animate in a human character as well as 3D objects being put in space inside of Maya. So in this scene we actually have a bunch of geometries to build. The cabinets, the walls, the furniture. We can pick and choose details that make sense to us, like the teapot, the chairs, the table, the things that make sense to actually build out as geometries. And the real challenge, or the interesting part of a piece like this, is really going to be this animated human person. So we're going to use the Human IK rig to manipulate a standard man character here. The thing that's special about HIK is what we call the full body mode, where instead of being a simple IK solver, it actually is able to have the different components of the body affect each other. If you pull hard enough on someone's fingertip, it's going to affect not just their arm but their entire body. And this kind of biological representation is a great way to get real biological accurate movement, which is really so important for this kind of assignment. So here's that animated mesh geometry brought back into the Flame here, and you can certainly see how you have the individual pieces here moving based on the camera move. You can see the different pieces of geometry in our scene. If I move back a little more, you can sort of see that. If I take a look at the wireframe view, you can see overlaid that moving character along with the static objects that are moving based on the camera move. And then it really is kind of a complete scene that we're looking at here. You can see the entire room laid out here from this perspective view, and picking essentially the details that you need. So picking the cabinets that you want to call out. Maybe you want to call out the teapot versus the ground. You don't need the leg of the table, as we never see that, and so on. So these are some of the decisions that you would make when you're doing this kind of thing. The next step, of course, is to project the content on, and we'll just fast track a little bit here to look at a further along composite here, where we've dealt with a few situations that relate to edges. Here we're using a combined masking and keying technique here to get some edge detail dealt with, and we've actually pulled out some of our kind of big iron keyers here, such as the 3D keyer. What we're able to do here is to actually deal with the different pieces, including difficult edges like hair edges here in different ways. So you can certainly refine down, change the different sections between a kind of a keying technique and a matte technique here. If we back out, you can sort of see how we define edges and then use a matte as a kind of a rough edge, but the keyer would be used as the fine edge on these different pieces. So these are the kind of building blocks. This is essentially to generate roto for this guy. But one of the things that you'll notice here is all these nodes called pixel spread, and these are one of the tools that we use to deal with the parallax artifact issue that I was going to show you right now. So if I actually just bypass my master pixel spread node there, I wanted to show you the issue that is caused when you do a projection. If you look at the projection view here, you can see how we've done a decent job of dealing with edges on the character himself, but we cannot get around from the issue of the artifact of his own projection in the backplate. So at this point I did not make a clean backplate. It's really just one image that's being projected, but I used the pixel spread technique to suck in the pixels based on the rotomat that we built to refine the edges of this guy to affect the background. So let me show you what I mean. If I come back to my pixel spread node here, I'm going to actually use this guy as a context view. So I'm going to look at that, but work on this. What you'll see is the issue that we have with our pixel spread turned off, and if I turn it on, you'll see it refined. The way this works is that it uses, if we just take a look at our pixel spread node itself, you can see the original the matte, and then the effect. And if I play with it a little bit, you can see how you can make this a more extreme effect. Of course, this is not going to hold up over hundreds of pixels, but it certainly might work over perhaps 30 or 40, 50 pixels as you need, and can give you a really cool result that can actually clean up your edges quite nicely. So you can make multiple deliverables for yourself from a comp. Here I have my rendered output in stereo. Of course, output mattes left and right. And in this case, I thought it'd be useful to output a Z-depth result, as you'll be able to see how useful this could be in the sort of final grading part of my my presentation we're going to look at right now. And the process here really is to take your timeline. So here's our timeline again, and put in the mattes that you want to use. So really, what I did here was I took this guy here and added in a few useful mattes. I added in essentially the individual pieces of the furniture and the guy and the tree there in the foreground, and then I added the depth matte as well. On other shots I did slightly different things. So if we step back out, you can see how each one of these purple containers had mattes assigned. So in here we can actually see here's some useful mattes for this guy. But also what we might do is just have a quick look at how you can use this as a sort of creative technique. So there you could have mattes for your mountains there. So just by attaching here in the timeline, I'm picking the different mountain ranges here as different isolation mattes that I've naturally built as part of my compositing in that case. And then along here at one of the earlier shots that we were looking at, you might remember the bird and the wall. I actually did some alternate renders. I've got a wall without the content, and I actually added a couple of other things in here. I've got some alternate materials. Here's a rock wall that's just a different look that I may be able to factor in as I do some creative grading in just a moment. So we've got our timeline. This is it right here, ready to go. So this one's completed and ready to be output by just putting it in a for grading library. I'm ready to start the process of final grading on this piece in stereo. So now let's take a look into the Flame Premium grading. Perhaps the last step in your process might be to do a final stereo grading or sweetening stage where you can come in here and bring your sequence from your library, and we'll take advantage of the timeline that has been made so far using the detailed mattes as we have them. But fundamentally, you might think, how different is this to working on a mono timeline? Well, certainly everything here, as you can see, is doubled up. These are your left and right layers exposed to you. You can see these matte container clips that we're going to come to as we go along. But ultimately, we work in very much the same way as we would in mono. We'll just use our dual view to see the content here. And dual view lets us look through, you can see left and right eyes simultaneously. These are also visible on your stereo capable projector or monitor. And if we just go about our business here of grading, you'll be able to see how this works. We'll just start using one of our input tools here. We'll work our way through the selective or secondary layers. We have up to 48 if we need them. But fundamentally, we might start by just setting an overall look. And this is the point where I might actually use the tactile interface here, our ACS panel, to define the overall look, perhaps working with master or even separated mid and low lift gamma gains in this case. So I want to really drop those blacks a little bit more. That's doable right here on the panel. Also available on the UI. But that might be our start sort of base level. We'll move up to one of our secondary layers here and do a separate saturation pass here, kind of isolations of individual colors. So I can override red, or perhaps I'll pick out this sort of mid-tone blue here for the denim of the jeans, and get something started there. So we'll just slim him down a little. And then layer 2 here, while we're still playing in real time on these two high def sources, what I'm going to do is I'll add a vignette, and you see how this is just a great way to make a matte that can be used inside and out intuitively here in our grading UI, where we can just work outside that for starters, and then go ahead and bring down the gain or the lift essentially of this layer to get that kind of vignetting going on. You'll see how this is working simultaneously on the two eyes, but that might be what makes sense here. Perhaps we'll just pull a quick key. I think I might pause at this point and pick the red of the lights here to get a matte that looks a little bit like this. I can refine my isolation if I'd like by moving the softness around here. If I want just the light, I might factor in a matte here to just cover up this light and follow that through in the scene as I need. But this is a great combination of techniques to then allow me to bring out the color of that light, or maybe overemphasize the color that I want. So you just keep building up, sculpting your shot like this. Perhaps we'll save that as a start point here to come back to in our grade bin. But then one more thing to do on this shot might be just to show you how we can use a number of cool trackers. We have this really cool one called a shape tracker. So we'll go to one more layer here, and we'll draw around the guy here so that you can see how things look. Again, working in stereo, I'm just picking out points that make sense to me. And instead of using a point tracker here, which could be useful in certain situations, I'll use a shape tracker to do an analysis of his movement via like the interior of his shape, which can be further refined if I'd like. I can add a soft edge to this. Let's do something sort of more like this. Put some grading in there, and then maybe we'll get an overall look of him brighter in the scene. If I want to, this might be a point where I might turn off the sync button to fix the edges of shapes in one eye versus the other, to just sort of dial in that offset, resync, and come back to grading now to make a change across them both. So these are some of the techniques I would use when working in stereo here. We might next up go down our timeline and start plugging in some of the grades that we made, see what we think of the different looks. Let's go with this one. Seems like it will work with a little bit of less gain in my input primary there. And then I might take that and propagate it further down the timeline. In fact, I can even take a look here at the entire sequence in a much more sort of a scalable view here. And let's just drag and drop that grade from 1 to many. And what you'll see is that this gives us a great way of coming down here. If we wanted to examine shots in a more relevant order, I might actually use my timeline assemble tool here to temporarily sort my timeline with heads and tails into C mode, or camera ascending timecode. What that does for me is that gives me all my similar shots together, stuff that was shot together, which just makes it that much more efficient to go through and manage and get the looks that I want quickly and easily. So one more thing to consider here might be working with the mattes that were generated in the timeline. Every one of these shots that has the purple box also has a matte attached. So let's just unsort our timeline. Go back to look at our timeline here, and you'll remember these shots here with their purple matte boxes. So let's just take a look in at some of the specific shots that we were working on. This one here has got a matte that allows us to work an interesting way. Let's just have a look. You can see there's mattes for the highlight, just for the lens flare here, so we can overdrive it, underdrive it here in the grading. So that's cool. But specifically, we might want to do something a little more surgical, even though we're at the end of our process, perhaps doing our final grading and sweetening in stereo here. What we might do is take a look at the mattes for this shot, which were there in those containers. Maybe I'll just shrink this matte slightly to really just get the back of the room as an isolation, a sort of a special kind of matte, if you like, that I can now use to get an interesting sort of look back there. If I take it all the way down, you'll be able to see how things look. What we'll do is we'll just use the gain here and drag it down for a kind of darkness in the back of the room kind of feel, which is kind of interesting. But we might then use that same matte again on another layer, but this time we'll use it inverted. So we'll come in here and we'll grab that matte, but use it as a way of just grabbing just the foreground elements. Now you could have separate mattes, of course, but I'm just showing you a little creative technique that I like to use, where you can then overdrive essentially the guy's hand at 100% and his body kind of like at 50% there. It's just an interesting way of using assets that you have to get different looks in the scene compared to the ungraded there. Cool. So one last thing I wanted to show you is the way that if you have shots like we had a little later here, you might be able to do even a bit more creative work on your comps. Even though we're here working on our sort of graded stereo media, I've got some mattes attached to this shot that we deliberately made to be able to work with, such as a shadow matte. So I could take my shadow here and I can put some darkness into that, and you'll be able to see how that's a great way of generating a shadow without having to render it into your comp. And then if you want none or if you want some, you can make that decision late in the game here. I'll use another layer here and another matte, so just sort of fishing around here for another matte such as this one, which is the bird itself, and we'll use that to just bring up the overall look of the bird and get it just so it's peaking at the level of white that we want in this scene here. So that's good. But then what about other creative stuff? What I actually added into this guy, you might remember, if we jump into this container here, was some more specific mattes, which are really just the textures of the different things in the scene. So this is just a fun way of being able to experiment late in the game. If we come back out here, what we'll do is we'll use one last layer here to actually define a specific texture to use to grade through, if you like. So if I go through here, look at some of my higher layers, you see this kind of elastic band representation of the wall, which is really an alternate render pass coming from the flame side of things here. And what we'll do is we'll actually grade through that. So what I mean is I'm going to use the luminance of that, and to get this kind of interesting sort of an effect here, maybe if we go outside of that, you can see how I could bring it down or just get a look that gives this a little bit more interesting an effect. Now, I don't want to affect my bird in here, so what I'll do is I'll come in and just link the different pieces together. I want to go through my Boolean ops here and decide that I want this kind of a holdout, and this is now a way that I can grade independently and get a look on my footage without affecting the bird layer. So that's just an interesting set of techniques. That's kind of what I wanted to show you here today. We'll just finish off by playing you back a kind of stereo work in progress master of this commercial from the guys at Digital Pictures.
What's going on here? Come on, fella.
I'm sitting in a railway station, got a ticket for my destination.
Hello, Mr. Dog.
Hi, Mr. Dove.
On a tour of one-night stands, my suitcase and guitar in hand. Every stop is neatly planned for a poet and a one-man band. Homeward bound, I wish I was homeward bound.
Thanks for listening and learning about 2D to 3D conversion with the Autodesk products. Please check out the area for our community site with lots of training tutorials on various topics. And if you'd like to know more about the 2D to 3D conversion process, there's actually an expert session that's being run by Sam Edwards, a VFX expert, that's being played at filmmakingwebinars.com on December 1st.